This is question number 9. Sketch the region and use a calculator to find the volumes of the solids formed when the regions are bounded by. So it's 2 to the x subtract 1 and 2 subtract x squared. And it's revolved about the x-axis. And the other option is revolving around y equals 3. All right, so since we get a calculator, we're going to use it. So to find the bounds, we have to make the two equal to each other. It's perpendicular. It's around the x and the y, so it's up and down revolving. We're going to go menu. You can't see this. There it is. You're going to go menu, algebra, and solve. And then you're going to actually type in the two equations. So you're going to type in 2 to the x minus 1. Move the cursor, equals, what's the second one? 2 subtract x squared, comma x, and then solve it. So one answer is 1, and then the other one is this irrational answer, negative blah, blah, blah. So those are going to be your limits that we're going to use. I got the wrong one here. So I got negative 1.3-ish and 1. So when I set this up with the x-axis, it's going to go from negative 1.343, let's say, up to 1. So the lower limit up to the upper limit, and we used our calculator to find it. Next, we're going to use our calculator to graph them. All right, so we're going to press the shaky calculator in the top left. This is not it. We're going to go, and I'll erase that right now. And so I'm going to press tab, and I'm going to type in 2 to the exponent x subtract 1. Then I'm going to press tab again, and I'm going to type in 2 subtract x squared. So just be aware of what you're looking at. So the blue is the exponential. The red here is going to be the parabola. I need to know what's on top and what's on the bottom. So can you clearly tell the parabola is above the exponential in that shaded region? That's what I was looking for. So because the parabola is on top, when I do the revolving, it's pi r squared. And you can tell when it's revolving around the x-axis that there's going to be a space. So I'm actually going to do a little sketch of this now that I see it. And I want you to notice there's going to be 2 radii involved here. So if I do a little sketch, let me do it up here. So if I do a little sketch, there's my parabola. There's my bad attempt at a exponential. Here's the shaded area. And I just want you to get a sense that there's a space here between the x-axis and there. And when you revolve around y equals 3, that's going to be way above there. There's a space there too. We need 2 radii. So when you're revolving, it's circles. And so I just like the template of pi r squared. So pi, those limits are there, r squared. So we have the big radius. Now, the big radius from the x-axis through the area then would be the parabola. That's going to be the upper one. So it's the parabola subtract 0, or just the parabola. So that's 2 subtract x squared. So that's pi r squared, subtract. And now it's the smaller radius. So if you go from the x-axis and only to the front of the area, that curve is the exponential. That's 2 to the exponent x minus 1. And then there's the setup. We'll now use your calculator to calculate it, but there's the setup to find the volumes. Oh, and this should be squared, right? Pi r squared. So pi r squared and pi r squared, the big radius subtract the small radius. All right, now let's type this in to get our volume. So I'm going to go back here to calculate it. I'm going to go to Menu, I'm going to go to Calculus, and Integrate. So I'm integrating from negative. Oops, let me do this. Let me just highlight, use my cursor pad and double click on it. Control C. Be careful that the negative didn't follow it over. So I need to make it negative. So click on the bottom box, Control V, and then go back and make sure it's negative in front. Now for the upper limit, it's just 1, so I can type that in. And then it starts with pi. Pi can be in front or behind it. So if you feel more comfortable, put pi in front, move the cursor, and then you can put pi in front. We're going to start with parentheses. In fact, we're going to start with 2 parentheses, and then we're going to type in 2 subtract x squared, and we're going to square it. Subtract another parentheses, and I'm going to type in 2 to the exponent x subtract 1. Again, I'm going to square it, and that's dx. Just double check that you typed it in correctly, that I typed it in correctly, and then go Control Enter for it, and I check the answer key to see that I matched or not, and I did. So it's 16.303. Oops. So if you revolve it around the x-axis, that's the answer. How does it change if you revolve it about the line y equals 3? So again, here's the line y equals 3. Just give yourself a visual so you can understand the big radius and the small radius. And you're always going top subtract bottom. So the beginning setup is the same. It's pi, it's negative 1.343 to 1. And we have 2 radii, so we'll start with 2 parentheses. So the first radius from the line of revolution all the way through the area, top subtract bottom is the exponential, is the bottom. So it's going to be 3 subtract the exponential, which is 2 to the exponent x minus 1 squared. Subtract now for the smaller radius, top subtract bottom, that's the parabola. So it's 3 subtract the parabola. Make sure that either you distribute or put parentheses around it. So I'll put parentheses around it. And then you have it. So when you subtract the exponential, it's fine. But when you subtract this with the 2 and the negative x squared, you need parentheses, or you need to write it as negative 2 plus x squared, and then you're going to square everything. This needs another parentheses right there. And then we're good. So that's what we're going to type in. Using a calculator is a skill, as I said before. Pi, menu, calculus, integration. I'm going to go Control V because it's already in the calculator, so I don't have to get. Just make sure it's negative. And then the upper limit is positive 1. Now this part, I'm going to start with 2 parentheses. And then I'm going to type in 3 subtract 2 to the exponent x subtract 1. And then I'm going to move the cursor and then square it. Subtract parentheses 3 subtract parentheses 2 subtract x squared parentheses oops, and then another parentheses. No, the other one's already there. Square it, and then dx. So try to be detailed. Make sure that you did your best. Make sure I did it right. Matching my answer key, 28.688 or 89. And you have your answer. All right, so the skill to use a calculator, we still need the skill to sketch and be able to set up and to show the setup in terms of what you're doing. We're on to number 10. All right, so from 10 on, these are review questions. So from 1 through 9 was this lesson, and now we're going to be doing some review. So for number 10, sketch the region and set up integrals for the volumes of solids formed by the given cross-section. So this was the lesson before. And so we have a region. So we have f at x equals the absolute value of x. We have y equals 0 and x equals -2. X equals 3. All right. And then I'm going to sketch that and then squares and then semicircles. So let's see if we can do that. So step 1 is, can I sketch that before I go any further? So I have an absolute value. I can do that. It looks like a V. It goes, have y equals 0, which is the x-axis. I'll do it in pink. So here's y equals 0. Here's the absolute value function here. It goes from -2 to 3. So let's say -2 and -3. And then what's the region that is trapped here is right here. So it kind of looks like two triangles that are going to be revolving around here. So the good news is I already actually know, I know my upper and lower limit. So it's already there at -2 and at 3. So I'm going to go from -2 to 3. It's a cross section. There's a cross section. There's squares to begin with. So the area for a square is to take one side and square it. And so the form that we're using is this. We take the area formula times dx to find the volume. So that's the area formula. We're going to go top subtract bottom when I do it. Now, the top is obviously the absolute value of x, and then the bottom is 0. So the absolute value of x, and then you square it. Just know that the absolute value of x and you square it means the same as x squared. They're equal to each other. Because if the answer is positive or negative, it wouldn't matter. Whatever number you put in, these are equivalent. So I just need to put x squared in terms of it. So this is the area formula. And we're going to put that in here. And that's what's going to give me the volume. Now for number 10, I think it said only the setup. Let me just double check. Just set it up. All right, so there's the setup for A. For B, it's the same start, -2 to 3. It's just the area formula changes when it's semicircles. So let's see if we remember semicircles. So for the area formula for a semicircle, it's 1/2 pi. That could be written in front of the integration. And then it's the radius. Well, the radius is half that base. So this, what I drew here, is the diameter. So the radius is going to be half of that. So that's the radius squared dx. And there's it is. All right, number 11. I'm going to turn the page. I feel like I got to move the camera a little bit here. I'm stretching over. Number 11. All right, so f at x equals 2 root x subtract x. Without using a calculator, what's the domain? So right away, the square root of x, the domain goes from 0 to infinity. Can't have any negative numbers inside there. B, what's the x-intercept? So make it equal to 0. and solve it. I should show you, right? So to find the x-intercepts, you make it equal to 0 and solve it. I'm going to solve this by adding x and then squaring both sides. So that would be 4x equals x squared. Make it equal to 0 and then factor. So there's the algebra that you need to be able to do. So by doing that, you can see the x-intercepts are at 0 and positive 4. So those are the x-intercepts. The next question, the maximum and minimum function values of f at x. So is there a maximum and a minimum function values of this? So that's calculus. So that's going to require the derivative. So to find maximum or minimum, take the derivative. Remember, this is like to the 1/2, so I'll even just write it to the 1/2. So 1/2 times 2 is 1. Subtract 1 to the exponent, and it's negative 1/2. Negative x is negative 1. Make it equal to 0. Add 1 to the other side. The solution to this is, since it's equal to 1, that x must be 1. So 1 to any exponent equals 1. So there's your answer. But then I got to figure out, is that a maximum or is that a minimum at 1? So this goes from 0 to infinity. So when I plug it into the derivative, if I plug in a number like 1/2 into this, you get a negative answer. If you plug in, 1/2 is the reciprocal there, so you're going to get a positive answer. If I plug in like 10 or 100 or 1,000,000, and because of that negative exponent, you're going to get a negative answer. So at 1 is actually a maximum. There is no minimum value. And then when you plug it in, because I think it said what's the function values, so that means I got to plug that answer in to find what it is. So the square root of 1 minus 1. So if I plug it in, the y value there is 1. So that is the maximum value right there. The last question, what is the range for this? And so to understand the range, because 1 is the maximum, the range is less than or equal to 1. So a little bit tricky. But since 1 is the maximum, so it would go from negative infinity up to 1. So it would go from negative infinity up to 1. And that would be the answer for the range. All right, that was number 11. Number 12 says show that the graph of f at x has no points of inflection, building a second derivative number line which indicates the concavity. So let's just build on what we did. Take the first derivative and take the derivative again. So the first derivative again was x to the negative 1/2. Subtract 1. That's this right here, the first derivative. Take the derivative again of that. So the second derivative gives you concavity. So that's negative 1/2 x, subtract 1 from the exponent, and that's negative 1. If you make it equal to 0, change this to be algebra friendly. So I'm going to write it as a fraction. So you end up with negative 1/2. This is in the denominator. If you like, you can write it as the square root of x cubed or not. You could just write it as a fractional exponent. But what's most important is the numerator here shows that there are no values that make the second derivative 0. So for a point inflection to happen, you have to be able to solve that equation. And because you can't solve it, there are no values that make it 0. So there are no point of inflection. In fact, no matter what number you put in here, it's going to be negative throughout because what you square root here, right? And there's a restriction, it has to be bigger than 0. So any positive number you put in here, show with the number line that the second derivative is always negative. There is no concavity change at all. So there's no point of inflection. There's no way to solve it. Number 13. In number 13, use the results from 11 and 12 to sketch a graph. And here I threw the paper away. All right. So what would the sketch look like? For me. So I know the max goes up to 1. And I know that 1 is an important number. And I also know what 4, right, is the other. I probably spread this out too much here. 1, 2, 3, 4. There we go. So 0, 0. You can just plug in 0 and know that's the beginning part of it. At 1 is a maximum. And then 0 and 4 are intercepts. This is concave down all the way through. Done. So we have a maximum at 1, 1. This is where it starts, the domain. We have X-intercepts at 0 and 4. They cross at each one, and it's over. And you can see the range from here, that it's 1 and below. 14. Find, we're still doing this, without using a calculator, can you integrate from 0 to 4 2 root x minus x dx? Let's do that. So when I integrate from 0 to 4, it's a definite integral. Technically, you're finding the area from 0 to 4 here. So this is the area you're finding by integrating that. I wrote it calculus friendly. To do this definite integral, do the antiderivative. So add 1 to the exponent. So if you add 1 to the exponent and then do the reciprocal, and then negative x, you add 1 and divide, and we're integrating from 0 to 4, and then just substitute in. So this is 4/3, plug in 4, and then subtract. Now when you plug in 0, the answer is 0. So this is that area. If you did need to simplify it, I'll do it for you. The square root of 4 is 2, and 2 cubed is 8. So it's 4 times 8 divided by 3. 4 squared is 16 divided by 2, which is 8. Common denominators makes this 32 take away 24, which is what, 8? And you have your answer. That's the answer I got. Let's see if that's the answer that was here. It is 8/3. Anyways, but what I put in the box, that's perfect and beautiful. You'd only have to do this if it was multiple choice. Number 15. We're almost there. So for number 15, find the average value of that same function. What? So from 0 to 4. So to find average value, we integrate the interval from 0 to 4. We integrate the function, which is 2 root x minus x, and then we divide by the difference of the bounds. Now, because we did this work to actually find the value of this, because this, we found the value of this already in the question before, that's 8/3. If I divide by 4, then you have your answer. So you could also write that as 3/4. So that makes it super simple that you already did the work for the numerator. Just divide it by 4 and you get your answer. Did I do it wrong? 8/12 is not 3/4, right? 4 and 4. It is 2/3. Haha. I thought I did something wrong. There it is. My spider sense went off. Number 16. Use a calculator to find C, where f at C equals the average for problem 15. We're back again at this. So to use a calculator to find where that is, the average value was 2/3. Make it equal to 2 root x, subtract x, and then solve it. So take the answer we did in number 15, make it equal to the function, and solve for x. So we're going to go menu. You can't see. So we're going to go menu. We're going to go algebra, and we're going to solve it. And what we're solving is 2/3, move the cursor, equals 2, and then root x, move the cursor, subtract x, comma x, and then control enter. So our interval was 0 to 4. So both of those answers are 0 to 4. So both of those answers are good. So both of these answers are in the interval 0 to 4. So we're going to write them both down. So 0.179 and 2.488. So 0.179, 2.488. At those x values, the average occurs. Number 17. We're going to be doing this for a bit here. 17, 18, and 19, and 20. So 17, find the instantaneous rate of change of that at x equals 2. Now, we already found the derivative. So instantaneous rate of change is the derivative. I already did the derivative. I didn't throw it away. So the derivative is x to the negative 1/2 minus 1. We already did that. And we want to find it at 2. So that's the derivative. We already did that. Here it is, back here, there, right here. And we want to find the derivative at 2. So, by the way, that's a great answer. But if you did have to reduce it down, the negative exponent means reciprocal. So it's the square root, like that. I think that's a good answer just the way it is. So that way, you need a calculator if you wanted to make it any prettier than that. So that's a good answer. Number 18, find the average rate of change. That would be the difference quotient, right? That's the slope formula. So that's f at 4, subtract f at 0, and then 4 subtract 0 in the denominator. So this is for the average rate of change, right? So if I plug in 4, the answer is, these are x-intercepts, right? So this is 0, take away 0, divided by 4. So that answer is 0. So I didn't even need to worry about it, because I remember these are x-intercepts. So when you plug in 4, the answer is 0. When you plug in 0, the answer is 0. 4, take away 0, the answer is 4. Divide, and the answer is 0. Number 19 is probably the mean value theorem. Is it continuous? Well, that's number 20. Is it continuous and differentiable from 0 to 4? And the answer is yes. So it is continuous from 0 to 4, and it is differentiable from 0 to 4. So at 0 you can't, but from 0 to 4 we're good. So the answer is yes to both. It is continuous and differentiable. And then number 20, might as well connect them together. If it was yes, it was. Then answer that for some C, and so on. So if the answer is yes, can you find where it occurs, where A rock equals I rock? So the first derivative equaling to 0, the average rate of change, and then solve it. So if I solve this, I already solved this equation like 3 questions back. This helped find the maximum. So if you take it equal to 0, add 1, we solved this already. So it occurs when x equals 1. So it occurs at that maximum value when A rock equals I rock. So it occurs when x equals 1. Then the last one, number 21. Sketch a graph of a function. Now this one's not connected to all the other questions before it. So this one's a brand new, fresh question. So I got to start with a fresh piece of paper. And then I'm going to write it down. Big question. I can do this. 21. Sketch a graph of f at x. Got it. Having the following characteristics. It's continuous. Beautiful. F at -2 and f at 0 are both equal to 0, which means those are x-intercepts. The first derivative at 0 is undefined, which likely means there's a cusp. Well, there is a cusp because it's continuous, so there's not a discontinuity. It means there's a sharp corner at 0. The first derivative, when it's bigger than 0, for x is less than -1, and for so on. So from when x is less than -1 and 0. So I'm going to do a number line so I don't get confused here. So I'm going to do a number line for the first derivative with -1 and 0 on it. And it says when x is less than -1, the derivative is positive. When x is bigger than 0, the derivative is positive. From -1 to 0, the derivative is negative. So I try to be a good reader, and I drew a number line. And so I got when it's less than -1, it's positive. Bigger than 0, it's positive. And between -1 and 0, it's negative. So I increase, decrease. So I know there's a maximum and I know there's a minimum at those values. What else do I know? Concavity. The second derivative is less than 0 for x is less than 0. So I'm going to draw a number line for the second derivative. I'll put 0 on there. So when x is less than 0, the concavity is negative. When x is bigger than 0, here, then the concavity is positive. And then can you sketch with that information? So try to be a good reader. This is the information I gleaned from it. So now I'm going to draw a graph based on it. So at the beginning, -2 gives you the answer 0. 0 gives you the answer 0. We're told that at -1, we have a maximum. I don't know where it occurs, but there's a maximum at -1. At 0, there's a minimum. I know where that is. And now we know concavity. So it's first concave down. And then it changes concavity at 0. So it's concave down, and then from 0 on, it's concave up. And let's see if everything is true here. So it increases, then decreases, then increases. That we have a maximum at -1 and a minimum at 0. That it's concave down up to 0, and then concave up after 0. At the derivative at 0 is undefined. So do you see the cusp or corner? That's a beautiful looking graph, and it's done. Your homework's done. Mr. G Math over and out. I'm proud of you for doing your work and doing your best. Till next time.